Have you ever wondered how a thermos can keep coffee hot for hours or keep ice water cold all day? It almost feels like magic. You pour steaming tea into a thermos in the morning and hours later it is still hot. At the same time, the same container can keep cold drinks icy even under the hot sun. So what is the secret behind this amazing invention? The answer lies in science insulation and controlling the movement of heat. A thermos, also called a vacuum flask, is specially designed to slow down heat transfer. Heat naturally moves from hot places to cold places. If you leave hot soup on a table, it cools down because the heat escapes into the air. Ice cream melts because heat from the environment moves into it. A thermos works by blocking these heat movements as much as possible. This is why it can protect both hot and cold items for a long time. To understand how a thermos works, we first need to know the three main ways heat travels. These are conduction, convection, and radiation. Conduction happens when heat moves through direct contact. For example, if you touch a hot pan, heat travels into your hand. Convection happens when liquids or gases move around and carry heat with them, like boiling water circulating in a pot. Radiation is heat traveling through invisible waves like warmth from the sun reaching Earth. A thermos is cleverly built to reduce all three types of heat transfer. The most important part is the vacuum layer. Inside the thermos, there are usually two walls with empty space between them. Most of the air is removed from this space, creating a vacuum. Since there are almost no particles inside a vacuum, heat cannot easily travel through conduction or convection. This is the thermos's biggest secret weapon. Think about space. Outer space is mostly a vacuum, which is why heat cannot travel easily there. A thermos uses the same scientific idea on a smaller scale. Without air molecules between the walls, heat has a very difficult time escaping or entering. This helps hot drinks stay hot and cold drinks stay cold. But what about radiation? Heat can still travel through invisible infrared waves. To reduce this, the inner walls of many thermos flasks are coated with shiny reflective material, often silver. These shiny surfaces reflect heat radiation back toward the liquid instead of letting it escape. If the drink is cold, the reflective layer helps keep outside heat away from the liquid. The lid also plays a very important role. Even if the walls are insulated, heat can escape through an open top. That is why thermos lids are tightly sealed. The seal prevents warm air from escaping and stops outside air from entering. Some lids are made with extra insulating materials to improve performance even more. Another interesting fact is that a thermos does not actually create heat or coldness. It simply slows down the transfer of heat. If you pour hot tea into it, the thermos tries to keep the heat inside. If you pour cold juice into it, the thermos tries to keep outside heat away. In other words, it preserves the original temperature for as long as possible. The quality of the thermos also matters. Cheap thermoses may lose heat faster because their vacuum layer or insulation is weaker. High-quality thermoses use better materials, stronger seals, and advanced insulation technology. Some modern thermoses can keep liquids hot or cold for more than 24 hours. Thermos technology is used in many areas of life beyond carrying drinks. Similar insulation systems are used in space exploration, medical storage, scientific laboratories, and even large food delivery systems. Vaccines and medicines often need temperature-controlled containers to remain effective. Without insulation technology, transporting these items safely would be much harder. There are also fun experiments you can try at home. Pour hot water into different containers like a glass metal cup and thermos. After a few hours, compare the temperatures. You will quickly notice how much better a thermos performs. This simple test shows the power of insulation science in everyday life. Next time you open a thermos and feel warm coffee hours after pouring it in, remember the clever engineering inside. A vacuum, reflective walls, and airtight seals all work together to fight heat transfer. It is a perfect example of how science can make daily life easier and more convenient. The thermos may look simple from the outside, but inside it uses powerful scientific principles that scientists and engineers have studied for years. From keeping your soup warm during winter to keeping your water cold in summer, this small invention quietly demonstrates the amazing science of temperature control. If you enjoyed learning about how a thermos keeps hot things hot and cold things cold, make sure to like and subscribe for more amazing science explanations. Thanks for watching.